All right, today everyone, we're going to be looking at using the law of cosines to solve an oblique triangle. We've covered the last couple of days the law of sines. Now we move on to the law of cosines. Again, it's important to understand you're only going to use law of sines or law of cosines when you're trying to solve in an oblique non-right triangle, okay? So you can see I have 1/3 of the law of cosines already written out here. It says if I take a side length, in this case A, and I square it, it should equal B squared plus C squared, so the other two side lengths squared and added together, but then subtracted by 2 times the product of B and C multiplied by cosine of A. So the big thing I want to draw your attention to is notice that the angle that we're working with here, A, matches the opposite side length of A. Okay, so if I follow that for B squared, the formula would look like A squared plus C squared minus 2AC cosine of angle B. If I'm working with C squared, that's going to equal A squared plus B squared minus 2AB times cosine of angle C. All right. And the situations where you're going to be able to use the law of cosines would be in a side scenario. So when you're given all 3 sides of the triangle and you don't know any of the angles, or in the situation of side angle side, where you're given 2 sides and an included angle. Okay, so let's cover side angle side situation first here. All right, it says find the length of the third side of a triangle that has sides of 3 centimeters and 7 centimeters with an angle of 130 degrees between them. So let me draw out something that's reasonably close to that. So we'll make this the 130 degree angle right here. I'll say this is the side length of 3 centimeters. This is the side length of 7 centimeters. And let's just assign some letters here. So A, B, C. And it wants us to find the third side length, so that would be side length B, right? Okay, so law of cosines would look like this for side length B. B squared would equal 3 squared plus 7 squared. So again, just the other 2 side lengths that we know, square both of them, added together, subtracted by 2 times the product of each of those, multiplied by cosine of our angle B, in this case 130 degrees. All right, now you are more than welcome. You can simplify all of this a little bit. So we'll say B squared is equal to 9 plus 49 minus 42 times cosine of 130 degrees, or B squared is equal to 58 minus 42 times cosine of 130 degrees. That's as far as you want to go. Common mistake that I get from students, they try to subtract 58 by the 42 here, but that would violate order of operations. So just leave it alone, okay? At this point, all I need to do to solve for B is square root both sides of my equation here, and now it's calculator work. Okay. So I have the square root of 58 minus 42 times cosine of 130. Again, make sure your calculator's in degree mode, of course. And I end up with a third side length of 9.2 centimeters roughly. Okay. So that is the side angle side situation. All right, now let's look at the side situation. Find all 3 angles for a triangle whose side lengths are 5, 10, and 12. Okay, so let me draw this out. I'll just make it look something like this. 5, 10, 12. Let's assign some letters here. I'll go A, B, C. All right, now notice what I have in red here. This is extremely important. So it says when you're given all three sides, so the side, side, side situation, always solve for the biggest angle first, okay? In doing so, that would show us if one of the angles is going to be obtuse or not. It would lead us to that obtuse angle first, okay? And once we have the obtuse angle, then we would be able to use the law of sines for the remaining two angles. If you don't follow this suggestion and you try to find one of the smaller angles first, then using the law of sines to find the other two angles could lead you to that ambiguous case, all right, that we would have more than one possibility for. So we want to avoid that, okay? So based on these side lengths here, the largest angle in this triangle is going to be the angle that is opposite the longest side, right? So in this case, that would be angle A, all right? So I'm going to set up the law of cosines for angle A here. Initially, that would look like 12 squared equals 10 squared plus 5 squared minus 2 times 10 times 5 times cosine of angle B. Or I'm sorry, angle A. All right, so let's do a little cleanup here. 12 squared is 144, 100, 25, 2 times 10 times 5 would be 100. Okay, so you subtract the 100 over and the 25 over. 144 minus 100 is, of course, 44. You subtract that by 25, you end up with 19, right? 19 is equal to negative 100 times cosine of angle A. Now divide the negative 100 over. Use an inverse function here. A is going to equal the inverse cosine of negative 19 over 100. All right, and think about this. You're taking inverse cosine of a negative value. That is going to put the angle in quadrant 2, right? And if it's in quadrant 2, it's an obtuse angle, okay? So let's see what we end up with here. Inverse cosine, negative 19 over 100, 101 degrees, 101.0 degrees. Okay, so let's fill that in. All right, and now that we found that obtuse angle, we can avoid the ambiguous case and use the law of sines to find my other two angles. So let's go after, how about we go after angle B next? Okay, that would be 5 squared is equal to 10 squared plus, oh, I'm starting to use the law of cosines again, sorry. Law of sines is what we said. So we could do sine of the 101 degree angle we just found divided by the opposite side length of 12, and that would equal sine of angle B divided by its opposite side length of 5. Cross multiply, 5 times sine of 101 equals 12 times sine of B. Divide the 12 over, then use an inverse sine function here. So B is going to equal the inverse sine of 5/12 times sine of 101. Let's see what we get there. Inverse sine 5 divided by 12 times sine of my previous angle of 101, right? I'm getting about 24.1 degrees. I'll fill that in. All right, and then we can do the same thing for angle C. I would use sine of 101 again over 12 equals sine of angle C over opposite side length of 10. So now we have 10 times sine of 101 equals 12 times sine of angle C. C is going to equal the inverse sine of 10/12. You can reduce that if you want to 5/6 times sine of 101. Okay. All right, so let's punch that in. Inverse sine, 5 divided by 6 times sine of the 101. Looking at 54.9 degrees. Okay. Now keep in mind, my other option to get that last answer, the value for theta, is I really could have just found C by taking 180 degrees and subtracting it by the sum of my other two angles, right? That should lead you to the 54.9 degrees as well. All right? So let's just circle them. 1, 2, 3.